Hello, this is Joe Reagan. Today I'd like to show you how to use SolidWorks to solve a simple truss problem. As you'll recall, trusses are made of members that are only loaded at the endpoints of the members and can only carry axial loads. That's to say there will be no bending stress and no shear stress in the truss members. So here we have a setup of a potential bridge truss. The dimensions are given here. The left end point will be set to have zero deflection in either direction, and the right end point as well. The cross-sectional area of the various members are given here. Young's modulus, Poisson's ratio, the yield strength, and the load. For case 1, we'll load this node here. Okay, so let's use SolidWorks to solve this problem. In SolidWorks, I've created a sketch that represents this truss. Next, I'll exit the sketch. Now I need to create some 3D geometry. I'm going to use weldments. So I'll click on my structural member. Now I've created some custom structural members to have the correct areas. Select the one that has 13 square centimeters area. It's just going to be a square profile. Now I'll select the horizontal. Okay, I've selected those. Now, typically you might want to add another group here, but sometimes the SolidWorks analysis module will compute the joints incorrectly if you group these and allow trimming. So I'm going to create that as its own structural member. Now I'll create another one, and these will be 13 square centimeters also. This one and this one. And this one, and this one, and I want to make sure my corner treatments are off. I'll zoom in and make sure it didn't trim. I do not want any trimming. This will ensure that my joints will be computed properly. So I'll check that. Then we'll click back and check what areas need to be next. Alright, the members labeled 2 are around the outside. They're 42 square centimeters. So we'll add another structural member. Go to the 42 square centimeter one. So it's here, 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 here. Okay, and finally for the 3 verticals, they're 20 square centimeters. Set the material to be a custom material that has the correct Young's modulus and Poisson's ratio. So now I'll create a study. It's a static study, and you see SolidWorks automatically computes the joints. These magenta spheres represent the joints of my truss. Now I'm going to convert the members into truss members. Okay, they default to beam members for structural members, but beams can carry bending stress, and we want to model it as a truss. Now all the structural members have been converted to truss elements, so we'll create some fixtures. I want to set the left joint and the right joint to have 0 translation. Now SolidWorks defaults to a 3D model, so we're going to have to constrain the Z direction on these members so that it will be adequately constrained. So we'll add fixtures and we'll use reference geometry. We will choose the front plane, and I want to set 0 motion allowed perpendicular to the front plane. So now I'll select the elements. Okay, I'll rotate the part, make sure I have them all constrained in the Z direction. It looks like we do. Spacebar, normal too. Alright, now we're ready to add the load. We're going to add the load to a joint. We'll give a reference plane as being the front plane, and now let's see which direction we need to add the force in. You see that one's running in the horizontal direction. That one's running in the vertical direction, so this is the force that we need, and we want 30,000 newtons. And the load is applied up now, so we want to reverse the direction so it'll be applied down. And we'll toggle that one off, and we'll increase our symbol size so we can see the arrow representing the force. Let's go ahead and run the model. Okay, so I had the simulation set up to create X displacement, Y displacement, and the maximum of axial and bending stress. Of course, all the bending stress is 0 in this model. If you want to investigate one of these further, you can right click or double click on it first to activate that. So this is the displacement, the Y displacement, and now we could probe and investigate the different elements. Okay, once you've probed each one of these nodes, you might want to save it as a sensor, and you can go back and load that anytime. Then that showed up as this workflow sensitive 1. Okay, and you could also save the results to an Excel file. Okay, and that Excel file would have in this case, all 3 displacement values plus the node numbers. Okay, and if you want to go back and load that same report, you can go into probe again, go from sensors. Now you can select the sensor since we've saved that set. And now if you wanted to see the labels displayed, you can click on it. Notice when you click on an element, it turns the one that you clicked on red. Hope that helps you explore modeling elements with trusses in SolidWorks. Thank you for listening. Goodbye.